everybody has always wanted to fly, and whenever people hear the term jetpack, that's what they really think about. So what we've done is we've reduced the amount of force. We're not able to fly with our jetpack, but we have instantaneous thrust, and we can pretty much trigger it to allow, for faster movements, agile motions, and so forth. With the project being called 4MM, for 4-minute mile, our overall goal is really to get any soldier or any test subject at the time to be able to run a 4-minute mile that wasn't already capable of doing so. Well, I started doing this research kind of by accident. The team at the time was just at the infancy of this project. So they initially came to me because I owned a welding business and was also a student here at the university.
And so we were developing robots that could assist amputees, and DARPA came back to us and asked us, could you develop robots that could assist able-bodied people and make them be able to run faster or do things that they couldn't do before?
And from there, things just kind of clicked because I was really interested in the robotic process. So the fact that I could work on designing something and then turn around and weld up a prototype the next day or even same day really reduced our overall time as a lab on getting ideas from concept to prototype.
We certainly had doubts about could you make someone run faster, and in fact Jason and I had tried to use a towing force with a golf cart to see if you could pull someone and allow them to run faster. So I personally ran around a track and then decided that yes, with the correct pulling force you could get someone to run a 4-minute mile. But the problem is, how do I apply those forces? Do I apply the forces on the trunk, or do I design an exoskeleton that applies forces at the hips and ankles?
But the more that we've kind of researched into it and found out potential applications, we found that in a warfare type arena, this could be potentially the difference between life and death. If you think of, a Navy SEAL or an Army soldier that has to get in somewhere quick and do whatever they got to do, but maybe get out of there just as quickly. So these devices can really help soldiers to not only accomplish their goals and succeed in their missions, but potentially save human lives as well. We're incredibly engineered as is, and augmenting our abilities really becomes a difficult, challenging research project that you don't know what the answer is going to be. Over trials over a 200-meter distance, we definitely saw a decrease in time and a decrease in what they call metabolic cost, the amount of energy required for a person to run at high speeds.
You ran with the jetpack 3 seconds faster, but you're also carrying an extra 11.2 pounds.
I really wouldn't have nearly as much accomplishment without the faculty and people here like Dr. Sugar that I work with. And if I can continue to work in this field, if I can continue to make wearable exoskeletons and robotic devices that assist people, then I'm feeling like I'm able to accomplish just about anything.